Yeah.
Okay.
Yeah.
So the first thing that we are going to be looking at today, today we're going to start a new chapter. So we're going to start with what we call beams, okay, which is also called statistics in other words, statistics in other modules. Okay. So today we are dealing with beams. These are very simple things to do, guys. Basically, like um, we just have to know how to do the calculations of these things and also how to move around the forces that will be acting on a beam. Okay, so I always give everyone a space that it's your first time doing this kind of thing. So we have to do from the basics. Okay, so let's say, for example, guys, is there anyone who remembers or anyone who can define for us a beam? What is a beam? Is there anyone who has an idea of what a beam is? Okay, so when we talk about a beam, guys, basically we're talking about um, any structure. A beam is any structure that can support forces. Okay, so basically that's a beam. We're talking about structures that can be able, or structures which are able to support what different forces. For example, guys, you know that we have what we call a bridge. A bridge looks like this. Okay, we have this thing, which will be, let's say, for example, with this. So basically, this is our bridge that looks like this. Then from this bridge, we're saying we're going to have forces which are going to go up. So let's say, for example, here I'm having this force going up like this, and also I'm having another force going up like this. Okay. So here we're having what? A load. So let's say, for example, this is a car that is traveling here, right? We're having a small car that is moving here. Okay, my car doesn't have a wheel. Okay, so we're having what? A small car which is traveling what? At this point here. So here we're going to have something like this. Then it comes to be like this. And we now say that this car, let's say, for example, is going to be weighing 1 kilonewton, right? So this basically like 1 kilonewton, which is equivalent to what? To 1,000 um, newtons like this. Okay, and here we're going to be having what reactions. They are gonna call it R1, and this reaction this side we're gonna call it what R2. So we have to understand that the reactions are always going to be what supporting the beam. In other words, they're always going to be going up. Okay, let me just close the windows because I'm hearing a lot of noise outside. Okay. Okay, so now the when we are dealing with beams, we just want to calculate the reactions at which R1 and R2 are going to be. That's basically the whole scenario that you're going to be dealing with. So we are saying here we're going to be having a distance, which is distance what S, and also here we're having what distance S, because we understand that whenever we are doing science, distance is represented by what letter S. Okay, so this S is in what in meters. Okay. So for us now to calculate this reaction that is happening at what R1 and R2, we have to first consider what we call moments. Okay, we have to consider what we call moments. So whenever we are dealing with moments, we are saying moment is equivalent to what? To the force multiplied by the distance. So when we are talking about a moment of a force, you're saying a moment of a force is a product of the force times the perpendicular distance from its fulcrum. Okay, so now since you're saying if a moment of a force is a product of the force times the distance, the force moves from what? From a fixed point. We are saying now, it's just an example. If now we apparently there are people who are failing to join. Let me just check. I don't understand what's happening with these links. Um, let me just check here. Okay, it was Mr. Silo, but I'm not having anyone in the lobby here. Okay, so let's take the example now, guys. We have this car here fixed at this point here, right? When this guy is fixed at that point, let me just mix this. When this guy is fixed at this point, if now let's say for example we lift up, let's say we lift up this force, this force lifts up here, going towards like this direction, so that now the beam is no longer straight, but it's landed like this, okay, like this, right? So we are saying at this end here, when we get to this point here, we are going to have what? Something that is going to stop this car from what? Keeping on moving, right? I want to ask you, if we lift this beam up, do you think the car is going to move in this direction or is going to move to this direction up to this point here?
It's gonna move down.
It will move down until the point here, which is point what? Point A, right? So now they'll ask you to calculate the reactions which R1 is going to have, right? So the first thing that you do, which is the first one, is to apply the law of moment, right? So what does the law of moments state? The law of moments from N3, we know that states that the summation of clockwise moments is equivalent to the summation of what? Anti-clockwise moments, right? Okay. So what are these things that we're calling moments? Just saying moments is a force multiplied by what? By the distance, right? Don't forget that whenever I say moment of a force, just know that I'm talking about a force times what? Times the distance that force is going to move. Okay. So now, since I have this moment, I have this force here, I'm saying this is R1 that I'm having here. So when we are calculating the reactions at this one, I'm going to say now number 2, right? We are saying fix R1, right? Sorry, R2. In other words, we are saying taking moments about R2. So the reason you say this force is going to move up to this one is because R2 is stationary. R2 is not what is not moving. But now, remember the car was moving all the way here up to this point, right? And also when this beam lifted, because remember the beam has got a weight on it. So that weight also it will be pushing until it wants to get to A. So now that's when you're gonna say now this force here is gonna move towards this direction, right? And this one is going to move towards what? This direction. And from the clock part, we know that if you're having a clock, something like this, we have a clock, something like this, right? We understand that clockwise moments, we talk about this movement here, then anti-clockwise is this movement here, right? So now when you're having R1, you can see that R1 is moving in the what? In the clockwise moment, which is going to be now R1 multiplied by the distance at which this R1 is going to move until it reaches A. If we say, for example, this R1 here has to move in a what? In a straight line like this, we will see that at the end of the day, when R1 moves, it will get to what? To this R2 after moving S plus S distance. So it's going to be plus what? 2S like this, right? then minus, because now the other one is going in the opposite direction, which is what the 1000 multiplied by what? By also 1s distance. So we're saying these moments are supposed to be equivalent what? To 0, right? So at the end of the day, we're now saying 2s R1 is equivalent to what? 1000 s, right? So we're going to divide everything by R1 s and also divide this thing by sorry, not R1, because we are looking for R1. So we're going to divide everything by what? By 2s, and also divide this thing by what? 2s, so that this one cancels this one, and our R1 is equivalent now to this s will cancel this s, then this one is going to be what? 5. So meaning that this is going to be what? 500 newtons. Okay. Are we together so far?
Yes.
All right. Now we want to now consider what, because remember what we do on the left, we're supposed to do also on the what, on the right. We cannot just do one thing on the left and we don't do the other one on the right. Yeah.
Sorry.
Yes.
Oh, sorry, sir, for disturbing. Sorry for disturbing, because I've been trying to raise my hand, and it seems like maybe you cannot see that. But you know, it wasn't audible from my side, so it only started being audible now. So, and I think I'm far behind. So I don't want to be left behind. I'm sorry for that. I've been trying to raise my hand, and maybe you didn't see that. So, and I think you're now going far and left behind.
Let me join with this one so that I think if I join with this one, it's going to be there. Even yesterday, I still remember like you had problems with your what they call it, hearing me and seeing my screen. I think, I don't know, maybe it's the network from your end, I don't know. But I'm going to repeat this one as well, it's fine. I'm going to repeat this, what I did here. So now, once we are at this point now, we are now saying, since we have gotten the value of R1, now we have to do R2 as well, so that you can know the reactions at which R2 is going to experience. So now we are saying now, this one, the R1 now is now fixed, right? The R1 is now fixed. Our R1 is now fixed, and we are tilting our what? Our beam like this. So meaning that everything now has to rush towards the end, which is this end here, right? So what's going to happen is that R2 is going to move like this, and the car is going to move like this. Okay. Are we together there? So we're saying this is the movement of what? Of the car. And this is the movement of what? Of R2. Okay, something like this, right? So now when you're having this, what you're going to say now is that we're going to do the same thing. We're saying taking moments about R1, right? So when we say taking moments about R1, in other words, as you're saying, R1 now becomes our official fulcrum, right? So now we're going to say now the summation of clockwise moments is equivalent to the summation of anti-clockwise moments like this, right? So I want to ask you guys from the floor, do you think that the car is going to move in the clockwise or anti-clockwise direction?
Anti-clockwise.
The car is moving in the anti-clockwise, right? So now we are saying if the car is moving in the anti-clockwise, it's going to be is equivalent to the force of that car multiplied by what? By S, right? Then what about R2? R2 is moving in the what? Is it clockwise or anti-clockwise?
Clockwise.
Clockwise. So this is going to be now R1 multiplying what? 2S. So sorry, R2 no, because it's R2 divided by 2S divided by what? 2S, meaning that now our R2 is equivalent to what? 500, like this, newtons. Okay, so at the end of the day now, when we are done with this, we need to know that the beam is in equilibrium. So we are now going to say that the upward forces is supposed to be equivalent to the what? Downward forces, right? So meaning that now we are saying upward forces is what? 500 plus 500, right? This is supposed to be equal to the force that is going down, which is what? 1000. So if you find out that at this stage here, your answers are not balancing, it means that you are what? You are wrong and you have to start again. Are we together on that one? Okay, so let's now, do you want me guys to give you another simple example like this one, or we can get a typical examination question?
Another example.
Another example. Okay. Let's say here I'm having something like now I'm gonna put forces. Let me divide this into two. So I'm going to say this. And I'm also going to this. Okay. So let's say I have a beam of this length, and I'm saying at this point here I'm having R left, and on this point here I'm having R right, and I'm having a force which is going down here. Let's say I'm having 10 newtons here, and I'm also going to have another force here that I can call maybe 50 newtons. Then I'm going to have 2 meters, I'm going to have 4 meters, and I'm going to have 3 meters like that. Okay, so we're having a typical question like that, and here remember the most important thing that we need to do here is to calculate the reactions at the support. So we want to calculate the reactions at this point and also at this point, right? So what we are going to do now is that the first thing that we have to do, we have to apply the laws of moment. So we are going to say now, I'm going to say checking moments about RR, right? RR to calculate RL. Okay. So this is the first thing that I'm going to do. Taking moments about RR to calculate RL. So Mr. Selo, since you didn't join us in the first part, here we are going to be explaining step by step how we did in the first stage as well. So now what you're going to do when you're saying taking moments about RR to calculate RL, we are saying our RR now, this one becomes our fulcrum, right? This one becomes the fulcrum of our page, our beam, which is a fixed point. Okay. So now, if this one becomes our fixed point, everything that we are having on this beam, whenever we apply a simple force to it, everything has to move towards that fixed point. So we're going to have these forces moving towards those fixed points like this, right? Okay, so now what we are going to do here is going to be saying now the summation of clockwise moments is supposed to be equivalent to the summation of anti-clockwise moment like this, right? So now if we're having something like this, we're saying now the summation of clockwise moment is equal to the summation of anti-clockwise moment. Then I want you guys from the floor now to give me some of these values. Okay, I want us guys to have all the clockwise moments that you are seeing. Can I have the first clockwise moment that you are seeing from the floor?
RL.
RL. So we're having now RL, and remember we are saying we need a moment. So RL is just a force. So but the moment is supposed to be a force multiplying by the distance that we have. So what would be the distance?
The total length from RL to RR. That's 2
Yeah,
plus
so
4 plus 3 most.
yeah, so that's going to be 2 plus 4, 6 plus 3, that's 9. So we're going to say RL multiplying what? Multiplying 9, okay? Do we have another clockwise moment?
No.
We don't. So it's equivalent to now, I need now anti-clockwise moment. Anti-clockwise moments, we can start from 50 because 50 you can see that already is moving towards that direction. So this is going to be what? 50 multiplying what? 5 meters, okay? Then I'm going to add again 10 multiplying what?
Oh, the tender.
Yes.
Why are you saying 50 multiplied by 5?
Oh, this looks like 5. Let me correct it. It's 3.
Doctor's handwriting.
So I'm going to put it as 3. Okay. So now we are saying 50 multiplied by 3 plus another one that is going to be 10 multiplied by what? 10 multiplied
7.
by 4. So the reason I'm writing 4, I wanted others to see. So but I think it's better if we just write it as 1. So I was gonna say 4 plus what? 3. Okay. So we are saying 10 from 10 until we get to the fulcrum. We have what? This 4 that you're having here plus what? The 3. That's 7. Okay. So meaning that this is going to be 9 RL is equivalent to 50 multiplied by 3. We are going to get 50, 100, 150. 150 plus what? 70. Okay, so meaning that 9 RL is equivalent to what? This is going to be equal 0. 15 plus 7 is how much?
20.
Is how much?
20.
220, okay. Yeah, so that's going to give us what? 220 newtons. Now, we divide everything now by what? By 9. This side we also divide by what? By 9, so that these 9s cancels out each other. So we're having RL is equivalent to what? Those ones with calculators, may you punch.
$24.44
Is how much?
Newton. 24.44 newtons.
24.44 newtons. Okay. So is there anyone who has a problem on this part first before we move further? Okay. So I think that no one is having a mistake there. So or a problem. If you have a problem, guys, don't be hesitant. Just like say, I'm having a problem, then you can try to assist each other. So the next point now that you're gonna have, since we say taking moments about RR to calculate RL, now we're going to say taking moments about RL, right? Now it's no longer RR, but it's now RL to calculate R. Okay. Now, after that, we're going to write the formula that we say the summation of what clockwise moments is equivalent to the summation of what anti-clockwise moments like this. Okay. So now, if we are saying the summation of clockwise moments equals summation of anti-clockwise moments, everything now has to change, isn't it? Because we are now saying this is now our fixed position, which is what RL. RL is now a fixed position. So whenever you say take moments about a value, everything on that beam has to go to that value. So this one now is going to go towards this direction. This one is going to go towards this direction. And now this one is going to go towards this direction. Okay. So I just want you guys to give me the clockwise moments that you're seeing. May I have all the clockwise moments that you are seeing, members?
It's the 24 plus 44 clockwise.
No, but remember, we are saying,
Working from the other side.
oh, here I made a mistake. Let me see to calculate RL, right? So RL. So now this one is our fixed point, so we are no longer considering it. So now we're having what? 10, right, as a clockwise moment multiplied by 2. Then plus, open bracket, we're having 50 multiplied by 6 is equivalent to, this is going to be RR multiplied by, this is going to be 4 plus 2, that's 6, 6 plus 3, that's 9. Okay, so most of the times, guys, whenever you're calculating the reactions, these ones, you find out that the moment of these reactions are the same. All of them are multiplied by 9, right? So meaning that this is going to be 20 plus 300 is equivalent to what? 9 R, right? So we divide everything by 9 and we divide everything by what? By 9. This one cancels this one. So now we are saying 320 over 9 is equals to what?
35.55.
So how much you get here?
35.55 newtons.
35.55 newtons is equivalent to what? To RR. Okay. So now we have calculated the reactions, but we have to test them now. So when we are testing them, so we are saying our upward forces are supposed to equate to what? Downward forces. Meaning that the upward forces, may I have the upward forces in this case? May I have the upward forces?
Is the 24.44?
Okay, so it's going to be now 24.44 plus 35.55 is equivalent to what? 50 plus what? 10, isn't it? How much do you get here?
I get 59.99.
So we're going to have 59.99 is equivalent to what? To 60. Do you think that we are correct or we are wrong in this case?
Correct.
We are correct.
We are correct because we are going to round off this thing to become what?
Nearest,
Equals
yeah.
to 60, right?
It's
Because if you round
true.
off 9, you can't round off to another number. So we just have to round off this whole thing to what? To 60. So meaning that 60 newtons is equivalent to what? 60 newtons. Then you are done. Is there anyone with a question on that one?
No.
Okay. So if there is no one with a question, I want to give you something to try, guys. Okay. Let's try this one. I want you guys to test all the answers as well on that one. So let's say here we are having A, and here we're going to have B, then here we're going to have 40 newtons, here we're having 60 newtons, and here we're having 30 newtons. Then you say from here to here, I have 2, here to here, from here to here, we're having 6, and from here to here, we're having 9. So these are meters, meters, and meters. May you guys calculate for me A and B, and also prove your prove your answers. In other words, you're saying test them. I'll give you guys 15 minutes to do that, so that we can move further. All right, guys, are we done?
Yes.
All right, so let's just do it together before we ask each other answers. I think that's gonna work. Okay, so I'm gonna draw it in a similar way, good. So I'm gonna have this like this. And I'll say that this is our A. And I'll say this is our B. And I'll say this is 40 newtons. And I'll say this is 60 newtons. And I'll say this is 9 meters. And I'll say this is 6 meters. And this is what 2 meters. Okay. Still I can see your hand is up. Okay. So I think you had raised it before. Now, when you're having this, what you're gonna have is to divide those things into.
Tatenda,
Yes.
exactly on top of B, you had a 30 Newton there, pushing down on that B.
Oh, thank you very much. So we have a force here, which is what? 13.
No, by me, it's 30.
30.
If I'm correct, yes.
Clarence, I think you are having a problem with joining, but I can see, where is it? You are here. So maybe, I don't know what was happening with your browser or the PC that you are using, but I have admitted you into this meeting a long time ago. So now, we need to get all the reactions here. So let me just divide this so that I don't end up not having space. So here we're gonna say now taking moments about D to calculate A. Taking moments about B to calculate A. So this is going to be now the summation of clockwise moments is equivalent to the summation of anti-clockwise moments like this. So now summation of clockwise, you're saying whenever we're having a clockwise moment, everything is supposed to go up like this. So, but before you do that, remember we are saying we can take, for example, taking moments about B to calculate A. So we're saying this one becomes our fulcrum. So everything is now going towards this direction. This one is going to go towards this direction. This one is going to go towards this direction. But now this one is already here, so there's nothing that it has to do, right? So may I have the clockwise moments that you're seeing?
A multiplied by 17.
So it's going to be A multiplying 17. Then do we have another clockwise moment?
No.
Is equivalent to now give me the anti-clockwise moments now.
40 multiplied by 15.
So it's going to be 40 multiplied by 15. So the 15 we're getting it from 6 plus 9, and the 17 is 6 plus 9 plus 2. Then we have another one which is equals to what? 60 multiplying 9, right? Then we close this bracket like this, meaning that now 17A is equivalent to 40 multiplied by 15 is how much?
600.
600. So I'm going to say 600 plus 60 multiplied by 9 is how much?
540.
540, meaning that 17A is equivalent to what? 600 plus 540 is how much?
1140.
Which is going to be 1140, meaning that your A at the end of the day is going to be how much?
67.005.
67.05 newtons, right? Okay.
Yes.
So when we have this one, now we're going to say now another one is what? Taking moments about A now, right? To calculate B, like this. Okay, so now we are going to say now the summation of what? Clockwise moment is equivalent to the summation of what? Anti-clockwise moment, right? So now we are saying A becomes our fulcrum at the moment. A is now our fulcrum, so everything is now moving towards A like that. So this one is going to move towards A, and this one is going to move towards A, and this one is going to move towards A, and this one is going to move towards A. The reason, guys, we didn't use 30 here, it was going to be a clockwise moment, but it was going to be plus what? 30 multiplied by 0 because of the distance, right? So now may I have the, what they call it, the clockwise moments.
The clockwise moments. 40 multiplied by 2.
So it's going to be now 40 multiplying 2, then plus we have another clockwise moment, which is how much? 60 multiplied by what? By 10, isn't it? By 8, sorry.
8, yeah.
Plus we have what? 30, right? Multiplied by 15, 17, sorry. Then that's it for clockwise moment is equal to anti-clockwise, which is equals to what? B multiplied by what?
17.
17. Okay, so here we are going to get 80 plus 60 multiplied by 8 is how much?
480.
480.
480 plus 30 multiplied by 17 is how much?
510.
510 is equivalent to what? 17b, right? So meaning that 80 plus 480 plus 510, how much do you get?
1070.
1070 is equals to what? 17b.
B.
So we divide everything by 17. Everything here by what? 17. This one cancels here, and this one cancels here. So meaning that our B is equivalent to how much?
62.9 Newton.
62.9
9 newtons.
newtons. Like this. Okay, but now we have to test this thing saying what? Upward forces is equals to what? Downward forces, right? So our upward forces, that's going to be what? A plus B is supposed to be equal to 40 plus 60 plus 30, meaning that A plus B, that's what we're gonna get as 67.05 multiplies 69.9 is supposed to be equal to, this is going to give us 130, right? Yeah. How much do you get here?
129.9.
So this is going to be 129.9 is equivalent to what? To 130. So meaning that 130 is equivalent to 130. Okay. Any questions there, guys?
No.
How many managed to get this one?
Myself.
Fusi, Monique.
I got it also.
Okay, what about Monique? Mr. Stella?
Oh, I was very far.
Oh, you're still very far. Where is Monique? Is she around or is she busy? Okay. Now we are going to continue. So basically this is the first part of it, right? So now we have to go to the second part. Now we have to remember whatever we're dealing with here, we call them direct forces or we call them normal reactional forces or direct loads, right? So what I see when now we're having other forces which are distributed across a certain path. For example, now we're having this like this. You also have this here. So now we're going to put a bar like this. Okay, so we are saying this is our beam, and we are going to have a force like this going up is R left, and we are going to have a force like this going down up again is R right, and we are also going to have a force here, let's say 10 newtons, and we have another one here is 50 newtons. Then in between here I'm going to put a normal distributed load. Sometimes it's represented by something like this. Then they'll put something and say 5 newtons per watt per meter. So this is going to be 5 meters. This is going to be another 5 meters. And this is going to be 3 meters. Okay. So here they'll ask you to calculate the reactions at the supports as well. So we are saying, guys, whenever you're having a force like this, straight force like this, we are calling it what? A direct force. Then if it's now like something like this, it's a what? Normal distributed load. And now, what you have to check now is to calculate reactions in this manner or in this scenario. The first thing that you have to do, we have to resolve this beam, right? So when we are resolving this beam, what we are saying here, guys, is that per every 5 meters that we are having, this beam is carrying 5 newtons. Are we together then? Per every 5 meters that we have, the beam is carrying what? 5 newtons. Meaning that now we're going to say, we're going to have something like...
Atenda,
Yes.
is the total distance of that beam 5 meters?
No, 5 meters, it's only from here to here.
Okay.
Okay. Now, what you have to do is to resolve this beam. So by resolving this beam, what do we mean? We mean that this beam is going to start to look like this now. It's going to have something like this. Then we are going to have a force going up. This is our RL. Then we are saying this is going to be 10 newtons. This is going to be our 5 meters. So now we are saying, guys, per every meter that we move, right? Per every meter that we move here, guys, we're saying we're having 5 and what? And 5. So 5 times 5, we get what? 25, isn't it? So meaning that from this point of 10 up to this point of 50, we are having 25 newtons, right? But now that 25 newtons has to be equally distributed within this beam, right? So when we are equally distributing it within the beam, it's going to be somewhere here, meaning that this is our 25 newtons, right? And from this end now, it's no longer 5, but it's actually now 2.5 here. And you're going to have another one, which is 50 here. And it's also going to be what? 2,5, and we are having 3 meters here, and we pull it out, we push it up like this to be what? R. Okay. Now, when you're having something like this, we are starting somewhere now. Now what we're gonna do, we are going to do the same thing that we've been doing, say taking moments about RR to calculate RL, meaning that our RR now becomes our fixed point, right? So if RR becomes the fixed point, everything has to go to what? To RR. So now we're saying this one has to move like this, and this one has to move like this, this one has to move like this, this one has to move like this. May I have the clockwise moments that you are seeing, guys? Summation of clockwise moments is equivalent to the summation of what? Anti-clockwise moments. May I have the clockwise moments that you are seeing here? May I have the clockwise moments that you are seeing here, guys?
Pardon me if I'm only responding to the end. I got a phone call, so I'm delayed a bit.
Okay. Why is it like you're the only one responding, guys? We have to discuss this thing together, right? Mr. Vosi,
You said clockwise moments. Now we start with RL, with a total distance, which is 5 plus 5 plus 3. So
so
it's
it's going to
13.
be RL multiplied by what? 5 plus 5 plus 10 plus 3 plus 18, right? I think we only have that clockwise moment is equivalent to our anti-clockwise moments. Now it's going to be 10 plus 8. Then also having another one, which is what? 25 multiplied by 5,5. Then we are also having another one, which is plus 50 multiplying what? 3. Then we close this, right? Meaning that 18 RL is equivalent to 80 plus 25 times 2, 5,5 is how much, guys?
137.5.
937. What? How much?
137.5.
Oh, 137.5 plus this is going to be 150, right?
Yes.
So meaning that 18 RL is equivalent to 80 plus 137.5 plus 150 is how much?
367.5.
0.5.
367.5. We are going to have 367.5. We are going to divide everything by 13. We divide also this one by what? 13. This one cancels here, and I having RL is equivalent to this one into this one is 1, and this one into this one is how much?
28.26.
28.26 newtons. Okay. Now, after this, we have to do also for the other reaction. So now we are saying taking moments. This one is too much. Taking moments about RL to get or to calculate RR, right? So meaning that taking moment about RL to calculate RR. So now it's going to be our clockwise moments is equivalent to what anti-clockwise moment,
Anti-clockwise.
like this, right? So everything is now coming to what to RL now, like this. This one. Wait. Taking moments about RR, everything was going to RR. Taking moments about RL, yeah, it's correct. So everything is now going this direction. Everything is now going this direction. Meaning that now the clockwise moments that you're having is what? 10 multiplied by 5, right?
Yes.
Plus the other one is what? 25
And 5
multiplied by
multiplied by 7.5.
7.5, right? Okay. Then plus another one that you're having is 50,
50 multiplied by
10,
10.
then is equivalent to what? RR
Or R.
multiplied by 13.
Yes.
So meaning that here is going to be 50 plus 25 point multiplied by 7.5 is how much?
1.5.
Is how much?
187.5.
So it's going to be 187.5 plus this is going to be 500 is equals to what? 13 RR, right? So meaning that how much do you get here?
The total is 287.5.
287.5. Okay, plus 500, right? Is equivalent to 13 RR. So we divide everything by 13, everything by 13. So this one into this one cancels this one, cancels this one, meaning that our RR is equals to what?
72.11.
Is how much?
72.11.
72.11 newtons. So now we have to take
Test.
so 28.26 plus 72.11 is supposed to be equal to 10 plus 25 plus 50. How much do you get here, guys, on this side? This side you're gonna get 60, that's 85 here. Not gonna balance, yeah.
Yeah, no, it's not.
So where did you go wrong? Calculations.
Yes.
Where do you, can you just go through the punching parts?
taking moments about RL to get RR. Thereby, second line 50 by, is it 10?
Yeah, it's 50 times 10.
Oh, okay. Moments about RR is correct.
I see where the problem lies, Tatenda. By the part where we had to add up 50 plus 500 plus 187.5 is equals to 737.5 divided by 13. If you divide that, then you get 56.73.
Oh, so it was here, right? Okay, so can you correct that part, guys? Because I'm basing with you. I don't have a calculator with me at the moment. So here you're saying how much are we supposed to get here?
I suppose now 50 plus 187.5 plus 500. It's supposed to be 737.5.
Then you divide it by 13. How much you get?
If you divide it by 13, 56.73.
56 point what? 73 newtons, right? So now, is it gonna balance now?
Yeah, it looks like it's gonna balance.
Damn, man.
It's not. Okay, let's start it together then. Let's start from taking moments about RR to get RL. So we are saying the RL multiplied by 13, that's correct, is equivalent to 10 multiplied by, this is 8 plus 25, 5,5 here. That's where the problem is. It's 5. 3 plus, that's correct. Then 50 times 3. Let's just confirm this one. So that's going to be 10 multiplied by 8 plus 25 multiplied by 5,5 plus 150. Then we get this one, we divide that one by 13, 2826. Okay, and the other one now is going to be 10 by 5 plus 25 by 7.5 plus 50 by 10. Okay, that's going to be 10 by 5 plus 25 multiplying 7.5 plus 10 by 5 plus 25 by 7.5 plus 50 by 10. This one dividing by 13, 56 point that one plus 28.26, 85. It's balancing, guys. 84.99. It is balancing, isn't it?
Yes.
Yeah.
Okay. Now, is there any other question on this part, guys?
Hey, Mutenda.
No.
Yes.
I don't know if I'm delaying the whole team or what. Like, cause I just understand everything after this thing is done by everyone. Cause like, now I'm just trying to understand how you were picking this clockwise numbers actually. So I only start understanding them now, and I feel like
Oh,
maybe if possible, maybe you can try another, maybe last example.
all
Maybe
right. No, it's not a problem. Let's try another example. Fine. Okay, so here I took a typical exam question, right? So remember, guys, when you're writing your exams or when you're writing the assessments that I'm going to share with you, I'm not going to draw the diagram for you. I'll actually write it down and you have to draw it from your own understandings, right? So here what we're going to have is that a light beam A, B, C, D, E is 11 meters long and is supported at B and E, right? So here I'm going to have my beam like this. So, and also we have this here. Okay, so a light beam ABC is 11 meters long and is being supported at A and E. So basically E is at the end here. Okay, so this is going to be our E and this is going to be our A. So B is 2 meters from the left end. So B is here, 2 meters from the left end. And E is at the right end. E is at the right end. C is 2 meters from the right of B. So C is to the right. So we're going to have another one which is also C here. So I'm saying this is our B, this is our C, and D is 4 meters to the right of C. So we're going to have also D here. Okay, the beams carries point loads of 5 and 4 kilonewtons at A. At point A.
The tender,
Mm-hmm.
the first line is then saying it is 11 meters long and it is supported at B and E.
Mm-hmm. Oh,
B
at
can't
B
be
and E, not A. Thank you, thank you. So here, this one is not here. B is actually this where it's supported. So when it's supported, it doesn't mean that it's hanging. So it's going to be from the bottom going up like this. Going to call this is B, and at A we have a point load, which is what? At points A and D. So 5 here, kilonewtons, and also 4 kilonewtons here. The uniform displaced load of 5 kilonewtons per meter is between point C and point D. So here we're having a normal distributed load like this. So this is going to be 5 kilonewtons per meter like this. Okay. Now, so let us put our values. We are saying this is 2, then to the right, and D is 4 to the, so here is 4, and I think we have another 2 here. Okay, so this is how you have to come up with the drawing, right? whenever I'm giving you these things, I'll need you guys to come up with a drawing like that. So now, is there a question?
No, not yet. I'm just scan reading through the question again.
Oh, all right. So we have to read the question and actually understand it. So now we're going to say this beam at the end of the day is gonna look like this. So we're going to say this is going to go down like this as 5 kilonewtons, and this is going to go like this as our B, and this is to go like this as our C, and this is to go like this as our D, and this is to go up like this as our E, like this, right? So, but remember here we are supposed to have a force here, right? So to get that force, you are saying 5 kilonewtons multiplied by 4, then you get 20, isn't it? Then here we are having 4, and here we are having like this. Okay, just a moment, guys. Just wanna answer. All right. So now this is 20. So do we all know, understand the part of resolving?
Katenda,
Mm-hmm.
is it now okay if you add the distance between C and D, those two, if you split the 4 by 2?
Okay, sharp. I can put it as 2 here, because we are saying it's going to be in the middle, right? Like that.
Yeah.
Okay. Any question on the before? Besides that,
Is it necessary to again write the Newton in simpler terms instead of like 5 kilonewtons? Is it okay to write it in like 5,000 newtons?
no, it doesn't matter. If now let's say for example you want to calculate your values in kilonewtons, please leave them in kilonewtons. So you find out that we'll be having 5 kilonewtons, 4 kilonewtons, and also your answers are supposed to be in kilonewtons. Don't change.
Okay.
So let's take this one. Let's move with it. So we're gonna say now taking moments. Taking moments about E to calculate B. So now what's going to happen is that if it's at E, Mr. Sailor, we are saying this one here is now our fulcrum, right? So everything is supposed to come to that what fulcrum. So everything is going to be moving like this to the fulcrum. There's no way that the 20 is going to go up like this to come to the fulcrum. There's no way. It has to slide like this. Then also this is going to move to the fulcrum, like this, and this is gonna move to the what? To the fulcrum like this. So now, Mr. Stella, I think you need to assist us on this one. So you're saying summation of clockwise moments is equivalent to what? Summation of anti-clockwise moments. So what I want you to do, Mr. Stella, is to give us the first clockwise moment that you are seeing from this diagram.
So,
4.
hello.
Yes, I can hear you. Can you hear us?
Yeah.
So I'm asking you to give us the first clockwise moment that you are seeing.
Okay. Referring from the previous example we had, ne? So, because it seems like okay, fine. Like from the previous one, okay, fine. We were adding. Okay, at the first one it was the one that we did before. We took actually like okay, the actual length of this thing of it was like it was RL. It did like RL times 13. Then the next thing it did like I don't know how to put this thing. Ne? I don't know how to put it. Actually. I don't know. It's in my mind, but I don't know how to put it.
Okay, it's fine. So we can see that you have 4 kilonewton.
Atenda,
Yes.
sorry to interrupt you again.
Mm.
Your 5 is a problem, I believe.
So it's 11. 2 plus 2, that's 4. 4 plus 2, 6. 6 plus, okay, yeah. 2, that's how much? 8. 8 minus 11, that's supposed to give us a 3. Thank you very much. Is it fine if I put a 3 now? 3. Is it correct now? Because 2 plus 2, that's 4. 4 plus 2, 6. 6 plus 2, 8, 9, 10, 11. That's 3. Okay. So the first clockwise moment, Mr. Seller, is like we have to check at this 4 here. So the 4 is moving like this. So it's going to be now 4 multiplied by 3. Then we are going to add again, right? 20 multiplying what? Multiplying 5. And also, yes.
Oh, I thought we starting from the other side. So it's starting from this side. I thought it's from 5 kilonewtons.
No, yeah, you're kind of breaking.
I'm saying I thought we starting from the other side.
From the other side.
Yeah, that's what I thought actually.
Okay, so if we want to take the other side, which is the clockwise, so we can only have B. So it's going to be now B multiplied by the total distance of B from the fulcrum, right? So it's going to be the total distance of B from the fulcrum. That's 2 plus 2, 4 plus 2, 6, then plus 3. That's going to give us 9. So it's going to be B multiplied by 9. We don't have any other clockwise moment. So if we don't have any other clockwise moment, we have to equate this. We have to say is equivalent to now 4 multiplying of what? Of 3. Then we are going to add, right? 20 multiplying of what? 5. Then you're also going to add again 5 multiplying 11. Meaning that 9B is equivalent to 12 plus 20 times 5, that's how much? That's 100, isn't it? Plus 55.
Atenda, why are we disregarding the C?
Because the C is just a value, so we are not going to say C multiplied by, how much is it? 7. C is just a value that is showing us. So for the reason they were putting this C, they wanted to have this explanation of a uniform distributed load is between point C and point D. So these values we use them now when we are drawing the shear force diagrams as well as the bending moments diagrams. So for today, we are not going to use it. So we are not using unknown variables. This C is just like the A that we have in here, as well as the A, B, C, then we're having another value here, and this D. You see, we didn't use the D because we used the 4. So we don't use the letters, we use the numbers, okay? So meaning that 9B is equivalent to this plus this, you're gonna get 155, 155 plus 12, that's how much?
$165. 167.
167.
Yes.
Okay, then we divide both sides by 9. Both sides by 9. This one cancels. Then B is equivalent to 167 over 9 is how much?
I get 118.11.
167 over 9.
167 over 9 years. I get I get 18.77.
18.77 newtons, right? Then we do the same thing and say taking moments,
It's 167 at the tender.
Yeah, it's 167. You said 100 plus 55, then we get 155. 155 plus 12, that's going to give us 167.
Oh yeah, okay, and then the final answer is 18.55.
Oh, not 77. All right. Let me cancel this.
It's kilonewtons, right?
Yeah. Oh, yeah. Thank you very much on that. It's kilonewtons as well. Okay. So now we're going to say taking moments about here we are saying about E, so now it's about B to calculate E, right? So now it's going to be taking moments about B. So that's going to be now everything has to go to B now. So here, this one is gonna go to B, this one is gonna go to B, this one is gonna go to B, and this one is gonna go to B, as well as this one is gonna go to B, meaning that the summation of clockwise moments is equivalent to the summation of anti-clockwise moments, like this. This is the same thing. Like this. Now it's defined. Okay, so now we're saying clockwise moments that you're having here. We're having C is moving towards this direction, but you're not considering C because there's no value here. So you're going to say now 20 multiplying what? 4. Then you're going to add 4 multiplying 2 plus 2, that's 4 plus 2, that's another 6. 4 multiplying 6, then that's all right, is equivalent to anti-clockwise. We're having what? B, we're going to have E, sorry, not B, multiplied by 9. But we still have another one, which is anti-clockwise, which is what? 5 by 2. So meaning that here is going to be 20 times this one is going to be 80 plus 4 multiplied by 6. 4 multiplied by 6 is how much?
Let's see. This is supposed to be that side. Okay.
That's 24, I think, just confirm, is equals to 9e plus 5 multiplied by 11 by 2, that's 10, isn't it? So meaning that 80 plus 24, we are going to get 104 is equals to 9e plus 10, meaning that now 104 minus 10 is equals to 9e. So now 104 minus 10, that's when we get what? 94. 94 is equals to what? 9e. So we divide everything by 9, everything by 9. This one cancels here, and this one cancels here. How much do you get for your E here?
10.44 kilonewtons.
10.44 kilos, right? So now we're going to balance it and say upward is equivalent to what? Downward. So our upward here, we are starting to have what? B plus E, that's 18.55 plus E, that's 10.44 is equivalent to 5 plus 20 plus 4. So here we are having 25, this is going to give us 29. Are we getting 29 on the other side?
Yes, 29 on the other side.
Alright, so this is balancing. Any questions, guys?
Your units, your units.
Kilonewtons. Kilonewtons. Okay, any questions, guys? All right, let me look for one for you. I have a lot of them. Can you do this one for me, guys? Okay, so I'm gonna give you guys 15 minutes again to do this one.
Uniformly distributed load. 5 He says 8 meters in total. Okay, let's not say less. Ah, nee. Supported by okay, A, B, C, so A, B, C, D, E. Okay. Oops. Open up, open up, open up. Hey.
All right, guys. So are we done?